take a minute to look at these 5 points here. Is what we're going to be working on hybridization. But hybridization is simply the mixing of orbitals of different energy to form new set of orbitals with the same energies. So if you're just hearing hybridization for the first time, that is what it is. This is copy chemistry and we help out with chemistry. So if you need help with chemistry, just reach out to us. Alright, so let's look at examples now. We're mixing the s orbital and then 2 of the p orbitals here. 1 s and then 2 p orbitals. It means that we're going to have a total of 3 orbitals and each of them is going to be sp2 because we're mixing 1s and 2 p's, okay? So each of them would be sp2, the same energy. But initially s and then p, they had different energies and different shapes. So that's what we mean when we talk about mixing of orbitals. Okay, over to the types of hybridization that we have. How do you even know the type of hybridization you have? You start off by identifying the orbitals. We have s, p, d, f orbitals. If you should mix them up, then you would eventually yield, you could mix 1s and 3 p's to get sp3, or 1s and 2 p's to get sp2, s and p to get sp. You could even mix sp3d, and so on. A lot of them can come up from this, okay? So you could have many of them. So these are the general types of hybridization. However, you might want to specifically look at hybridization in carbon, and there are mainly 3 types. So that's where you have the sp3, the sp2, and the sp. The sp3 occurs in alkanes, that's the single bonds. Your sp2 occur in alkenes, that's where you have the double bond, like ethene. And then right here, alkynes, that's sp. These ones are so straight, and then they are linear in shape. We'll see that later on. Okay, so let's look at the sp3 hybridization proper. This one occurs in alkanes, as we have said, but carbon has a number of 6, and that's the configuration there in its ground state. However, the same carbon can be written in its excited state, where one of the electrons in the s orbital moves to join the p orbital this way. So this is the excited state of carbon. You will appreciate it more if we draw the orbitals exactly. So I'm going to do boxes around here. So that jumps over to here. Okay, so eventually you'd have something like this. 1 is left here, and now this becomes 3. Now it's excited. It is the excited state of carbon that does the hybridization. Very important. Hybridization happens in the excited state of carbon. Okay, so now let's talk about the sp3. What are we mixing here? 1s and then 3 p orbitals. So eventually we're going to form 4 orbitals eventually. And each of those 4 orbitals will be called sp3. Each of them. When we mix them, okay? So this is just the mixing here. 1s and then 3p of them to give 4 sp3 hybrid orbitals. Do you have any questions so far? If you have any questions, leave them in the comments. And then we have sp2 hybridization, same way, but here we're mixing s and then 2 of the p's. Okay, you know this one happens in double bonds, like we've already said. So we need to have at least 2 carbon atoms here. And then you'd notice that there's 1 unpaired electron there that is unhybridized for the first carbon and the second carbon. That's what gives you the pi bond that's there. Same thing happens here. You see 2 unhybridized, and that gives you the 2 pi bonds there. And of course, you have one normal single bond. So eventually it has a triple. On the right here is a summary table just telling you the hybridization, the example, the shape, and the bond angle. So take time to go over this. If you have any questions, leave them in the comments. Now let's tackle some questions finding out the hybridization. Would want to draw this out and tackle them carefully. So here the hybridization of carbon is sp3 hybridized. Why? Because you have single bonds. If you go back to the table, you will see it clearly. sp3 hybridized here. This one has a double bond on the carbon, so that makes it sp2 hybridized. So basically that's the answer to this. sp3, sp3, sp2. That's the hybridization for this one. So we could have even more tougher questions. Let's try this one. What is the hybridization present here? Eventually you will be drawing them out, but you see this hydrogen here is s hybridized, so take note of that. That hydrogen is s hybridized, but we're focusing on the carbon now, so that carbon has a triple bond, so it's going to be sp hybridized. Okay, we find that in alkynes. This one also has a triple on the left and a single on the right, so we're taking the triple. That's the sp as well. This one is all single bonds around, so that's going to be sp3. What of that? All single bonds around. This one has a double bond on the right, so we're taking the double bond. That makes it sp2 hybridized. Okay, the carbon F there has a double bond on the left, so we're taking sp2. And that's basically the answer to this one. Pretty easy. You could also be identifying the type of bond present, not the carbon now, but the bond type with respect to hybridization. So we're looking at the bond that holds two things across. That bond is holding C, which is sp3 hybridized, and then that H over there, which we've said is S hybridized. So that means that that bond is an S to sp3 bond. S to sp3 bond. Or you can say sp3 to S bond. Either way, you're right. Similarly, that's an S to sp3 bond. That one as well is an S to sp3 bond. Okay, check this out. That's sp3, that's also sp2. Remember, double bond there. So that means that this bond is an sp3 to sp2 bond. Okay? So let's also check out that one there. So that's an sp2 to S bond because the hydrogen is S, remember. We can also switch it around. Then that is an sp2 to sp2 because the two carbons there, they have a double bond. How about this one? sp2 to S. I will also do other ones as well. So let's analyze this other bond here. The carbon is sp2, right? The oxygen is actually sp2 as well. Okay, so eventually those bonds there are sp2 to sp2 bonds. So let me show you something down here. If you have something like this, the oxygen there is sp2. This oxygen down here is also sp2. Okay, I know we're focusing on the carbon now. I just wanted you guys to know about the oxygen as well. Right, so the next question is on percentage S character of the sp3 hybridization. If you come back here, you see that this is sp3, right? It means you're mixing one S and 3 of the P's to get 4 sp3s. So if you're looking at the percentage S character, it's like you take a fraction S out of the sp3, then times 100%. So the S is like 1, the sp3 is like 4 things together, okay? And then you have 1 over 4. So basically S over sp3 times 100%, which translates to 1 over 4 times 100%. That's a 25% there, right? So we can apply the same thing for B, sp2. So that's S over sp2. We're looking for the percentage S character here, and then that's how we do it. For this one is simply 1 over 2 times 100%, which gives you 50%. I hope this is helping. So those are your answers over there. You can also be asked to calculate the percentage p character, and you will do that one. Alright guys, so have fun.